Okay, in this video, we're going to work on writing piecewise functions. So the first thing I do is I start with my labels. Now, these are dotted lines that I marked. These aren't asymptotes. I marked them to show that this is where the graph changes, okay? Where the graph changes, you have a less than side and a greater than side, a less than side and a greater than side, okay? To the left is always less than, to the right is greater than. What value of x does the graph change or make a jump? At 3. So this is going to be 3, and over here it's going to be negative, not negative. This is negative 3, and this is positive 2. Okay. So we're going to start with this equation here. And we need to first recognize that it's linear. You're looking, most of these are going to be linear, or they'll be parabola, so there'll be a quadratic, or there could be some exponential. But usually, if they're asking you to write the equation, they keep it fairly simple, and it's usually a quadratic or a linear equation. So the first thing I'm going to do is find my slope. So my slope is down 1 over 1. So negative 1, 1. So my slope is negative 1. If I continue to go down 1 over 1, down 1 over 1, down 1 over 1, I learned that my y-intercept would be what value? Negative 3. So my b is negative 3. Who can tell me this green line? I know it's not colored on your paper, but the green line, what is the equation of the green line? Yep. Florent, which? Excellent. Negative x minus 3. Now, there is a restriction. I only graph this when what? X is what? Less than negative 3. Can x equal negative 3? Look at the graph carefully. Can x equal negative 3? Yes, because it's a solid dot right there. So less than or equal to negative 3. Good? Okay with that so far? Okay, next I notice that I have a flat line. A flat line is a what? Constant. What is the constant value of the purple line? 4. So y equals 4 from where to where? From negative 3 all the way to 2. So x is sandwiched in between. Yes, x is sandwiched in between. Are either of these equal to? Which side's equal to? The 2, because if you look at 2, the dot is closed, solid. Good? All right, so there's kind of a cheat on the next one. If you notice, somebody already wrote the equation for you on your paper. What's the equation for the blue? Negative x plus 5. And what is the restriction? Okay, why did you choose greater than? Okay, but why greater than? You're correct, but why greater than? Because the graph is to the right. The graph is to the right of the break, it's greater than. To the left, it's less than. Okay? Question. Okay, so let me ask you this. This is a good one. This is the tricky one when x is sandwiched, right? So, over here, is x bigger than 3, negative 3, or smaller than negative 3? Bigger. So if you notice right here, this symbol is saying negative 3 is smaller than x. The other way, I know, and it's probably a bad way, is that teachers used to say the alligator eats the bigger piece. I do it differently. Here's a dot, here's 2 dots. 2 dots is more than 1, so x is more than negative 3. It does get tricky. But when it's sandwiched between, it ends up being 2 less thans. Because when you do the 2 less, well, they're not technically less than, but if I was ignoring and just looking at the direction, those would both look like 2 less thans. But when I read it as a full sentence, it's a greater than and less than because x is sandwiched in between. Okay. All right, so let's go ahead and try the next one on your paper before you do some on your own. Let me clear the annotation. All right. So here we have, what type of graphs do we have here? We have a constant and a linear. I'm going to give you 90 seconds to try on your own. Okay, first thing I do, hold on, let me give you a hint though, is I put in a line where the discontinuity occurs. Okay, and this side is less than, this side is greater than. Take it from there. Okay, so the jump is at -2, and this is a constant, so y equals 1, and the restriction is x less than or equal to -2. Okay, great. Now for the second graph, I believe this is an open circle. Yeah, okay. I did check because my highlighter covered it over. Okay, so who wants to take a guess at the equation for that one, or tell me the equation for that one? Yes. All right, x, because my y-intercept is 0. Great. If x, say that last part again, greater than -2. And y isn't an equal to? How do I know that it's not equal to? There's a hole. There's an open circle, okay? All right. And what type of discontinuity is this? Jump. Good, good, good. I'm going to keep so that we never forget any of the information. That's why I keep asking those questions, so it keeps coming around, okay? All right. So I'm going to do one that has a parabola, so we're going to skip ahead, okay? And then I'm going to let you practice some on your own. So if you look at your worksheet, here we're going to do the one on the left-hand side, bottom row, left-hand side of the back. Okay, first of all, is this parabola in standard position? How do I know it's in standard position? The vertex is at 0, 0. On a side note, is this in standard position? No. Where did it relocate? It moved up 1, so this is going to be a +1, okay? All right, so I have 1, 2, 3 equations. And let me get out my highlighter. There's a break. There's a break. Okay, so we have less than, greater than, less than, greater than. The first break occurs at what value? Negative. Now I see -2. All right, and then this one is at 1. Okay, so this is, somebody already called it out. This is a constant of what value? So y equals -3 when x is less than -2. Not equal to because it's an open circle, okay? All right, what is the equation of this graph? X squared. Great, x squared. From where to where? -2. Is it equal to or not? Equal to. And it ends at 1. Equal to or not? Not. Okay, great. And the last equation. What's my slope? Okay, 2 over 1 is my slope. So it's going to be 2x. Now, if I go down 2 over 1, what is my y-intercept? 0. So my equation is just going to be 2x, and the restriction, x is greater than or equal to 1. Okay, I know I've done it right because see when numbers repeat? See when numbers repeat? Then that only, if number repeats, only one of them can have an equal to. It's not possible for it to be equal to at 2 locations, okay? Good? All right, so that leaves you with 3 to try on your own, please.